When determining feeder sizes for subpanels, several factors must be considered, including the ampacity of the subpanel, the length of the feeder run, the type of wire used, and applicable electrical codes. For a 125 amp subpanel, it is important to understand the appropriate American wire gauge, or AUG, sizes for both aluminum and copper feeders. Generally, for a 125 amp subpanel, you would typically use number 2 AWG aluminum or number 4 AWG copper feeders. When selecting a wire type, it is important to note that Romex or NMB cable is not suitable for outdoor use. Instead, you should use underground feeder or off-beat cable, which is rated for both indoor and outdoor applications. Considering feeder run length, the required wire size can vary. For a 35-foot run to a subpanel, number 4 AWG aluminum or number 6 AWG copper UFB cable is generally sufficient for 125 amps. However, for a longer 70-foot run, you would need number 2 AWG aluminum or number 4 AWG copper UFB cable to maintain the same ampacity. Cost considerations play a role in the decision between aluminum and copper wire. Aluminum wire is typically less expensive than copper wire. However, it is important to note that aluminum wire may require a larger conduit to meet bending radius requirements, as specified by the National Electrical Code, or NEC. The overall cost difference between using aluminum and copper feeders might not be significant, particularly for shorter runs, when considering the additional materials and labor required for larger conduit. To illustrate, let's consider some recommended feeder sizes for different ampacities and run lengths. For panel number 1, which has a 35-foot run, the following options are available. Firstly, number 4 AWG aluminum UFB cable, which is suitable for 90 amps. Secondly, number 6 AWG copper UFB cable, which is suitable for 100 amps. And thirdly, number 4 AWG aluminum UFB cable, which is suitable for 125 amps. For panel number 2, which has a 70-foot run, the following options are available. Firstly, number 2 AWG aluminum UFB cable, which is suitable for 90 amps. Secondly, number 4 AWG copper UFB cable, which is suitable for 100 amps. And thirdly, number 2 AWG aluminum UFB cable, which is suitable for 125 amps. It is crucial to base the ampacity of the feeders on the largest potential load of the subpanels, ensuring that the wiring can handle the expected demand. Proper conduit and fittings must be used for all feeders to protect the wiring and comply with electrical codes. It is strongly recommended that all electrical work be performed by a qualified electrician, adhering to all applicable codes and standards to ensure safety and compliance. Let's delve deeper into the technical considerations for selecting the appropriate feeder size for subpanels. When determining the correct wire gauge for a subpanel feeder, several factors come into play, including ampacity, voltage drop, and the type of insulation. The NEC provides tables and guidelines to ensure that conductors are adequately sized to carry the intended load without overheating or causing excessive voltage drop. Ampacity refers to the current carrying capacity of a conductor, measured in amps. The NEC specifies the ampacity of various conductors based on their material, size, and insulation type. For example, copper conductors typically have a higher ampacity than aluminum conductors of the same size due to copper's superior conductivity. The insulation type also affects ampacity, as different insulation materials have different temperature ratings. Higher temperature ratings allow for higher ampacities. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, conductors must be sized appropriately for the length of the run and the amount of current they will carry. Longer runs and higher current loads require larger conductors to reduce resistance and voltage drop. The type of insulation used for the conductors also affects voltage drop. Conductors with low resistance, such as copper, will have less voltage drop than conductors with higher resistance, such as aluminum, for the same size and length. When selecting conductors for subpanel feeders, it is essential to consult the NEC tables and guidelines to determine the appropriate size and type of wire. These tables provide ampacity ratings for various conductors based on their material, size, insulation type, and installation conditions. Additionally, the NEC provides formulas and guidelines for calculating voltage drop to ensure that conductors are adequately sized to minimize voltage drop. In addition to ampacity and voltage drop, other factors to consider when selecting conductors for subpanel feeders include the environmental conditions in which the conductors will be installed, the type of equipment they will be connected to, and any applicable local codes or regulations. For example, conductors installed in wet or corrosive environments must be specifically rated for those conditions. Similarly, conductors connected to certain types of equipment may need to meet specific requirements for flexibility or insulation type. It is also important to consider the physical installation of the conductors. Conductors must be properly supported and protected from physical damage. The NEC provides guidelines for the installation of conductors, including requirements for conduit cable trays and other support systems. Proper installation is essential to ensure the safety and reliability of the electrical system. When working with electrical systems, it is always best to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to properly design and install electrical systems that meet all applicable codes and regulations. They can also help to ensure that the electrical system is safe and reliable. Let's consider the specifics of using UFB cable for subpanel feeders. UFB cable is a type of underground feeder cable that is designed for direct burial in the earth. It is commonly used for residential and commercial applications where conductors need to be run underground. UFB cable consists of insulated conductors encased in a moisture-resistant outer jacket. The conductors are typically made of copper or aluminum and are available in various sizes and insulation types. The outer jacket is typically made of polyvinyl chloride, or PVC, and provides protection against moisture, chemicals, and physical damage. UFB cable is suitable for both wet and dry locations and can be installed in direct contact with the earth. It is commonly used for running power to detached garages, sheds, and other outbuildings. It can also be used for underground branch circuits for outdoor lighting and receptacles. When installing a UFB cable, it is important to follow the NEC guidelines for burial depth and protection. The NEC specifies the minimum burial depth for UFB cable based on the voltage of the circuit and the type of location. In general, UFB cable must be buried deeper in areas where it is subject to vehicular traffic or physical damage. The NEC also requires that UFB cable be protected from physical damage by installing it in conduit or other protective raceway. Conduit is a rigid or flexible tube that is used to enclose and protect electrical conductors. It is commonly made of metal or plastic and is available in various sizes and types. Conduit provides mechanical protection for conductors and helps to prevent damage from moisture, chemicals, and physical abuse. When installing UFB cable in conduit, it is important to use the correct type and size of conduit for the application. The NEC provides guidelines for selecting the appropriate type of conduit based on the environmental conditions and the type of conductors being installed. It is also important to ensure that the conduit is properly supported and secured to prevent damage or displacement. In addition to conduit, other protective raceways can be used to protect UFB cable. These include cable trays, cable ladders, and other support systems. These systems provide mechanical support and protection for conductors and can be used in a variety of applications. When selecting a protective raceway for a UFB cable, it is important to consider the environmental conditions, the type of conductors being installed, and any applicable local codes or regulations. Proper installation of UFB cable and its associated protective raceways is essential to ensure the safety and reliability of the electrical system. It is always best to consult with a qualified electrician or electrical engineer when designing and installing underground electrical systems. These professionals have the knowledge and experience to properly select and install UFB cable and other components to meet all applicable codes and regulations. It is important to ensure that the electrical system is safe and reliable. When considering the ampacity of conductors, several factors can affect the actual current carrying capacity of a wire. These factors include the ambient temperature, the number of conductors in a raceway or cable, and the presence of thermal insulation. The NEC provides adjustment and correction factors to account for these conditions. Ambient temperature refers to the temperature of the surrounding air or environment in which the conductors are installed. Higher ambient temperatures can reduce the ampacity of conductors, as the conductors are less able to dissipate heat. The NEC provides correction factors to adjust the ampacity of conductors based on the ambient temperature. These correction factors are typically expressed as a percentage of the base ampacity rating. For example, if the ambient temperature is higher than the temperature rating of the conductor insulation, the ampacity must be reduced by a certain percentage. The number of conductors in a raceway or cable can also affect the ampacity of conductors. When multiple conductors are installed in close proximity, they can generate heat that reduces the overall ampacity of the conductors. The NEC provides adjustment factors to account for the number of conductors in a raceway or cable. These adjustment factors are typically expressed as a percentage of the base ampacity rating. For example, if there are more than 3 current-carrying conductors in a raceway, the ampacity of each conductor must be reduced by a certain percentage. The presence of thermal insulation can also affect the ampacity of conductors. Thermal insulation can trap heat around conductors, reducing their ability to dissipate heat. The NEC provides guidelines for the installation of conductors in thermal insulation. In general, conductors should not be installed in thermal insulation unless they are specifically rated for that purpose. If conductors must be installed in thermal insulation, their ampacity must be reduced to account for the reduced heat dissipation. When determining the ampacity of conductors, it is important to consider all of these factors and apply the appropriate adjustment and correction factors. The NEC provides detailed tables and guidelines for calculating the ampacity of conductors under various conditions. It is always best to consult with a qualified electrician or electrical engineer when designing and installing electrical systems to ensure that the conductors are adequately sized and protected. Let's discuss the importance of using proper conduit and fittings for subpanel feeders. Conduit and fittings are essential components of an electrical system that provide mechanical protection for conductors and help to prevent damage from moisture, chemicals, and physical abuse. Conduit is a rigid or flexible tube that is used to enclose and protect electrical conductors. It is commonly made of metal or plastic and is available in various sizes and types. Metal conduit provides excellent mechanical protection and is often used in industrial and commercial applications. Plastic conduit is lightweight and corrosion resistant and is often used in residential and underground applications. Fittings are used to connect conduit sections together and to connect conduit to electrical boxes and equipment. Fittings are available in various types, including couplings, elbows, connectors, and bushings. It is important to use the correct type and size of fitting for the application to ensure a secure and watertight connection. When selecting conduit and fittings for subpanel feeders, it is important to consider the environmental conditions, the type of conductors being installed, and any applicable local codes or regulations. For example, conduit and fittings installed in wet or corrosive environments must be specifically rated for those conditions. Similarly, conduit and fittings used for underground installations must be suitable for direct burial. The NEC provides detailed guidelines for the selection and installation of conduit and fittings. It specifies the types of conduit and fittings that are permitted for various applications and provides requirements for supporting and securing conduit. Proper installation of conduit and fittings is essential to ensure the safety and reliability of the electrical system. Conduit must be properly supported to prevent sagging or displacement. Fittings must be securely tightened to prevent moisture from entering the conduit system. When working with conduit and fittings, it is important to use the correct tools and techniques. Conduit benders are used to bend conduit to the desired shape. Threading tools are used to create threads on conduit ends for connection to fittings. Proper grounding and bonding are also essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Bonding connects all metal parts of the electrical system together to create an equipotential plane, which helps to prevent voltage differences that can cause electrical shock. The NEC provides detailed guidelines for grounding and bonding electrical systems. It specifies the types of grounding and bonding conductors that are required and provides requirements for connecting grounding and bonding conductors to electrical equipment and structures. Proper grounding and bonding are essential to ensure the safety of the electrical system. It is always best to consult with a qualified electrician or electrical engineer when designing and installing electrical systems to ensure that the system is properly grounded and bonded. The NEC is updated every 3 years and includes changes to address new technologies, safety concerns, and industry best practices. Staying up to date with the latest NEC requirements is essential for ensuring the safety and compliance of electrical systems. Many jurisdictions adopt the NEC as their local electrical code. However, some jurisdictions may make amendments to the NEC to address local conditions or concerns. It is important to be aware of any local amendments to the NEC that may be in effect in your area. In addition to the NEC, other standards and regulations may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or UL. It is important to be aware of all applicable standards and regulations when designing and installing electrical systems. Continuing education is essential for electrical professionals to stay up to date with the latest codes, standards, and technologies. Many organizations offer continuing education courses and training programs for electrical professionals. These courses can help electrical professionals to maintain their licenses and certifications and to improve their knowledge and skills. Safety is paramount when working with electrical systems. Electrical shock can be fatal. It is important to follow all safety precautions when working with electricity. Always de-energize circuits before working on them. Use insulated tools and equipment. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not qualified to work on electrical systems, do not attempt to do so. Hire a qualified electrician to perform the work. By following these safety precautions, you can help to prevent electrical accidents and injuries.